today's lecture, I'm going to solve problem 10.10. The questions from 10.9 up to 10.19. The data for all these questions are given in the table, and the problem statement is that we have squared and ground in springs. We have to check those springs whether they are solid safe or not, and if they are not solid safe, then what is the longest free length for these springs such that the factor of safety for the spring is 1.2, or in other words we can say that what is the maximum length of that spring for which that spring will be solid safe. So the data for question 10.10 is this one, where diameter of the wire is 0.014 inches, the external diameter of the spring is 0.128 inches, and the length of the spring in free state is 0.5 inches, and total number of coil of the spring are 16. The material used for the spring is phosphorus and bronze, which is an alloy. First of all, let's find out the mean coil diameter of the spring. Let's take the top view of the spring. So this will be the internal diameter of the spring, and this one will be the external diameter of the spring. The distance from this point up to this point will be the mean coil diameter, and this is the wire diameter D. And if you subtract this distance, which is equal to R, and this distance from the external diameter, that will give you mean coil diameter. So OD minus R, and the 2 minus R will give you D, will be equal to mean coil diameter. So D is equal to OD minus D. So for this problem, this is the given data. This is how we can find out the mean coil diameter, which is equal to OD minus wire diameter, small d. As external diameter, OD is equal to 0.128 inches and wire diameter is equal to 0.014. So putting these values, it will give you mean coil diameter D is equal to 0.114 inches. Now from mean coil diameter and wire diameter, we can find out the value of the C, which is equal to mean coil diameter divided by wire diameter. And if you see over here, this D is equal to 0.114 inches and wire diameter is 0.014 inches. So putting these values, it will give you C is equal to 8.143. Now using the value of C, we can find out the value of Burgester factor, which is KB, and that is equal to 4C plus 2 divided by 4C minus 3. So put the value of the C, it will give you KB is equal to 1.169. As total number of coils are given, so using table 10.1 we can find out number of active coils. Using this total number of active coils, we can find out the value of spring rate K, and that K value can be used to find out the value of the force F, and this force is equal to K into Y, and K is equal to D power 4 G divided by 8 D cube NA. This G value can be found out from table 10.5. Wire diameter and mean coil diameter are given to you. What you will have to do is to find NA, for which table 10.1 is used. So let's find out NA value from table 10.1. So in the table 10.1, look at to the squared and ground in spring, and NT is equal to NA plus 2, so NA is equal to NT minus 2. As NT is equal to 16, so NA will be equal to 14 coils. So we know the value of wire diameter, mean coil diameter, and number of active coils. Now let's find out the value of this G from table 10.5. So for phosphorus and bronze alloy, and the value of the G for it is 6 megapsi. So putting all these values in the formula of K, it will give you K is equal to 1.389. Now Fs is equal to K into Ys, which is equal to K into L0 minus Ls. K value is this and L0 value is this. Now to find Fs, we will have to find Ls, for which we can use table 10.1. So in the table, look to the squared and ground in spring. So for that, Ls is equal to D and T, as the value of D is equal to 0.014 inches and NT is equal to 16. So put the value of D and NT, it will give you Ls is equal to 0.224 inches. So after finding out the value of Ls, we can find out the value of Fs, and putting the values, Fs will be equal to 1.389 into L0, which is 0.5, minus Ls, which is 0.224, which will give you 0.3834. Now let's find out the value of tau s, which is equal to kb into 8fd divided by pi d cube. Fs is 0.3834 lbf, d is equal to 0.114 inches, kb is equal to 1.169, and d is equal to 0.014 inches. So putting all these values, it will give you tau s is equal to 47.42 kilo-psi. Factor of safety is equal to torsional yield strength SSY divided by tau s, and SSY is equal to some percentage of SUT, and SUT is equal to R divided by d to the power m. A and m values can be taken from table 10.4, and in table 10.4 for phosphorus and bronze, these three rows can be used, And if you see the wire diameter as 0.014 inches, which is in this range, so the value of m is equal to 0 and the value of a is equal to 145. So let's put these values into this equation. So it will give you SUT is equal to 145 kilo psi. Now, as SSY is equal to some percentage of SUT, so this percentage can be found from table 10.6. Since phosphorus and bronze is non-ferrous alloy, so for non-ferrous alloy, this percentage is 35 before its removal. So multiply this 145 with 0.35, it will give you SSY equal to 47.25 kilo psi. If you see this SSY is less than instead of using Fs is equal to 0.3834 LBF, use Fs is equal to K into L0 minus Ls, where K is 1.389 LBF per inch. Mean coil diameter is 0.114 inches and wire diameter is 0.014 inches. So putting all these values and rearrange this equation for Ys, it will give you Ys is equal to 0.229 inches. Here Ys is the deflection of the springs when it is forced to be deflected from free state to solid state. So Ys is equal to L0 minus Ls. Then L0 will be equal to Ys plus Ls. So putting values, it will give you Ls is equal to 0.453 inches. Thanks for watching the lecture, and if you want to get further updates on